Hello everybody. So this is another problem related to cables. So we went through one of the problems in the previous video, and this is the fourth problem, problem number 4. I solved problem number 1 in the previous video, which was a general problem, and this is the second type, which is problem number 4 in your notes. This is problem number 4 in your notes, and again you're supposed to find the same thing: tension T in all the cable segments. Tension T or tension running through all the cable segments should be found. The unknown is same. So what is the difference between this particular problem and the previous problem which we went through in the previous video? The difference is this. Here, the inclination of the extreme segment is not given. Whereas in the previous problem, the inclination of all the segments were known. It was given. But here, the inclination of the extreme segment, the left extreme segment, is unknown, which is given as theta. You don't know the inclination of the segment. This is the main difference between this particular problem and the previous problem. So this is all about the problem. You have 1, 2, 3 cable segments, 3 segments, and A and D are the supports. And step number 1 is always to identify the junction points. So B is one of the junction points and C is the other junction point. Right. So once you identify the junction point, you'll be marking the forces. Step number 3 is to mark the forces which runs through all the cable segments. And when you mark the force, make sure that force always moves away from the junction points. Force always moves away from the junction points. For example, let me consider this junction point to be. Force always moves away. So this will be T, B, A, which moves away. Again, force moves away here. T, B, C. Let us consider C now. Force moves away. T, C, B. Both T, C, B and T, B, C are same. Let us consider this now. This will be T, C, B. These two are not the cable segments. These two are the suspended loads of 100 and 800 Newton magnitude. So we have completed marking the forces now. Marking the forces. So if this angle is 30, even this will be equal to 30. If this angle is 60, even this will be equal to 60. Now let us draw the free body diagram. Drawing free body diagram will be the next step. Next upcoming step will be drawing free body diagram. So I have already drawn the coordinates now. I've already drawn the coordinates and I have marked the suspended loads. Let us mark all the force associated with the junction point B. Junction point B. So let us go through this. So you have TBA. So you have TBA and angle made by TBA with respect to horizontal is theta. You have TBC. TBC and angle made with respect to horizontal is 30 degrees. And even this angle should be equal to 30. So this is TCB and you have TCD. TCD, which makes an angle of 60. So this is the free body diagram, what you have. This is the free body diagram. And you are supposed to find the value of TCD, TCB or TBC and TB. Tension through all the cable segments. The only difference is with respect to this particular angle theta. Theta is unknown here, whereas in the previous problem theta was known. We knew the value of theta, but here we don't know the value of theta. This is the main difference. Again, we have completed drawing the free body diagrams. Once we finish drawing the free body diagram, what are we supposed to do? We have to go through the free body diagram. When you have two free body diagrams, you have to select that particular free body diagram with least number of unknowns. That particular free body diagram with least number of unknowns. Let us go through both the free body diagrams now. Let us go to the free body diagram of junction point B. So it has TBA, 1 unknown, TBC, 2 unknowns. Free body diagram of junction point C, TCB, 1 unknown, and TCD will be the second unknown. So both the free body diagrams have equal number of unknowns now. Both the free body diagrams have equal number of unknowns. So now which free body diagram is to be selected if it has equal number of unknowns? Just to check here, theta is also one of the unknowns, is it not? As far as the free body diagram of junction point B is concerned, theta is also one of the unknowns. We don't know the angle, it is one of the unknowns, is it not? So total number of unknowns as far as junction point B is concerned are 1, 2 and 3. TBA, theta and TBC. Theta is also one of the unknowns. So it becomes 3. So let us concentrate on the free body diagram of junction C now. So as far as free body diagram of junction C is concerned, only TCB and TCD are unknown. You know the angles. So you will be selecting the free body diagram of junction C first because it has least number of unknowns. You know all the angles here, you don't know all the angles. So let us select the free body diagram of junction C first. Let me draw it separately. So suspended load is 800 newtons. This is T, C, D, and this is T, C, B. This angle is 30 degrees and the other angle is 60. So this is junction point C. So check the number of forces now. Check the number of forces. Total number of forces 1, 2, and 3. Total number of forces 1, 2, 3, and you know all the angles. So we can straight away apply Lami's theorem since it has 3 forces. Let us apply Lami's theorem. So according to Lami's theorem, it will be TCB divided by sine of angle between the other two forces. TCB divided by sine of angle between TCD and 800, which is 90 plus 60, 150 degrees. Sine 150 is equal to TCD by sine of angle between the other two forces, TCB and 800. This is 90 plus 30, this will be 120. Sine 120 is equal to 800 by sine angle between TCB and TCD, this angle which is 90. Sine 90. Again, these two terms have unknowns and this particular term has no unknowns. Equate the unknowns with the known one. So let this be the equation number 1 and let this be equation number 2. Equation number 2. So from first equation, from equation number 1, it is TCD by sine 120 is equal to 800 by sine 90. So therefore TCD is equal to, get the value of TCD by multiplying 800 by sine 120 divided by sine 90. This will give you the value of TCD as 692.8. 692.8 newtons. TCD 692.8. Again, so from equation 2, this is equation 1. We have completed equation 1. So equation 2 is TCB by sine 150 is equal to 800 by sine 90. Again, TCB is the only one. You can find the value of TCB and you'll get the value of TCB as 400. TCB as 400. So you got TCD and you got TCB. TCB is equal to TBC. So even TBC will be equal to 400 newtons. Even TBC will be equal to 400 newtons. So we have completed one of the junctions now. We have completed one of the junctions. Let us go with the other junction. Let us go with the other junction. So the only force which is unknown is TBA now. TBA is the only force which is unknown. Let us try to find the magnitude of TBA. We got the value of TBC. TCB is equal to TBC. So if TCB is 400, even TBC will be equal to 400. So let us concentrate on the free body diagram of junction point B. So the suspended load is 100 newtons. This is TBA now. TBA making an angle theta, the unknown angle. And this is TBC, which is equal to 400 newtons, and this angle is. So this is the free body diagram of junction point B. This is the free body diagram of junction point B. Now, so even though the total number of forces in this particular system is 3, you cannot apply Lami's theorem. You cannot apply Lami's. The only limitation here is this particular angle. In order to apply Lami's theorem, we should know angle between all the forces, is it not? We should know angle between all the forces. According to Lami's theorem, a particular force is proportional to the angle between the other two forces. Now, to apply Lami's theorem, we should know the angle between all the forces. But here, the angle between all the forces is not given. Theta is unknown, so you cannot apply Lami's theorem. So, since you cannot apply Lami's theorem, the only alternative is to apply conditions of equilibrium. There are only 2 ways. If you can apply Lami's theorem, it's well and good. You can go with Lami's theorem. If you cannot apply Lami's theorem, the only way out is to apply the conditions of equilibrium. So, which are the conditions of equilibrium that we have? We have summation of fx equal to 0 and we have summation of fy equal to 0. These are the 2 conditions of equilibrium that we have. Now, in order to apply these 2 conditions, we have to resolve the inclined forces into their horizontal and vertical components. Let me resolve this. This will be 400 cos 30. Vertical component will be minus 400 sine 30. Minus sign indicates that this moves vertically downwards. So let me resolve this as well. The horizontal component is minus TBA cos theta, and the vertical component is TBA sin theta. TBA sin theta. Now let us apply the conditions. Let us apply the conditions of equilibrium. The first condition is summation of Fx equal to 0. Summation of Fx equal to 0. So let us list down all the forces which moves along x direction. So it will be minus TBA cos theta minus TBA cos theta plus 400 cos 30 is equal to 0. You just have two forces. Let me express this in terms of TBA. Let me take this to the other side. So finally I'll get TBA cos theta. TBA cos theta is equal to 400 cos 30. Let me consider this as equation number 1. Equation number 1. Let me apply the second condition of equilibrium. Second condition of equilibrium, which is summation of Fy equal to 0. Summation of Fy equal to 0. So second condition of equilibrium will be in this way. So the suspended load is minus 100 newtons, minus 100, minus 100. So minus 400, minus 100 minus 400 sine 30, sine 30 plus TBA sine theta is equal to 0. So let me express this in terms of TBA sine theta. Therefore, TBA sine theta is equal to 100 plus 400 sine t. Let me consider this as equation number 2. Equation number 2. So we have two equations now. The first equation is in terms of TBA cos theta, and the second equation is in terms of TBA sine theta. TBA sine theta. So what is to be done? Since we have two equations, what are we supposed to do? Now, since we have two equations, the first equation is in terms of TBA cos theta, and the second equation is in terms of TBA sine theta. So we can divide equation 2 by 1. Equation 2 divided by 1. Equation 2 divided by 1. Equation 2 is TBA sine theta, and equation 1 is TBA cos theta is equal to, right hand side is 100 plus 400 sine 30 divided by 400 cos. We have divided equation 2 by equation 1. Equation 2 divided by equation 1. So when we divide equation 2 by equation 1, TB and TBA gets cancelled. Sine theta by cos theta will be tan theta. Tan theta will be equal to something. This value will be equal to this particular value when you solve. So you get the value of theta. Theta will be tan inverse of this particular value. You get the value of theta very easily. You get the value of theta very easily. So once you get the value of theta, you have to substitute the value of theta in one of the equations, either in equation 1 or equation 2. So once you get the value of theta, you have to substitute theta in equation 1. Equation 1 is TBA sine theta is equal to 100 plus 400 cos sine 30, and TBA cos equal. This is equation 2. So in either of the, or this is equation 1 or equation 2. In either of these equations, in equation 1 or 2, you get the value of TBA. You get the value of TBA. So this is how we are supposed to do if you have an unknown angle. Problem is easy. So since you have an unknown angle, even though you have three forces, you cannot apply Lamy's theorem. This is the major disadvantage. You have to go with the conditions of equilibrium. So you have one more problem of similar type in the notes. Please try to solve it along with this. Thank you.